All right, you guys, so this is measure and classify angles. Okay, so first off, we have to define angle, and that is two different rays with the same endpoint. Okay, so as you can see, we have this ray AB and we have this ray AC, and they both start at A. So this is what we mean by having the same endpoint. Okay, so this is an angle, angle BAC, and this, since it's the common endpoint, is our vertex of the angle. Okay. And we also have sides of an angle, and the rays are the sides. Okay? So there's two different ways to name an angle. The first one is the letter of the vertex. So as long as you only have one angle here, I can easily call this angle A. Okay? The second way is with three letters. And since we have 3 points on our ray, we can use any 3 points on the ray. The only thing is that the vertex has to be the middle letter when we name it. Okay? So I'm going to call this angle BAC. We start at one end, we go to B, then A, then C, but we can also call it angle CAB. So order doesn't matter, but A, the vertex, must be in the middle. Okay? We also have to classify angles. So we have 4 different types. Okay? We have an acute angle, and acute angles measure between 0 and 90 degrees. We have right angles. These will always be identified with a little box in the corner, okay? And those angles always measure 90 degrees. We have obtuse angles. Obtuse angles are more than 90 degrees, but less than 180 degrees, okay? And we have a straight angle, and we hardly ever see a straight angle, but it does help to know that a straight line on one side of a straight line, we always have 180 degrees, and that will be helpful in a lot of the problems, okay? So let's take a look at some examples. Example 1, it says name and classify each angle. So if I look at A, what I have there is that little box. And remember, we said that is 90 degrees. So my pen will work here. 90 degrees. This is a right angle. Okay, so I just classified it. It's 90 degrees. I also want to name it, so I can name it 3 different ways, right? I only have one angle here. I can call it angle D. I can also call it angle FDE, and I can also call it angle EDF. Okay? Any one of those names will work. Okay? For letter B, excuse me, it says name and classify. So here I have a 30-degree angle. So I'm going to say angle LMN. That is what kind of angle? That is a acute angle, right? I also have angle OML. Okay? And that is what kind of angle? It's a obtuse angle. Okay, and there's actually a third angle, okay, and the third angle is the large one, which is angle OMN, okay, and angle OMN is actually if I add these two together. So it's obviously obtuse, but that leads us into the angle addition postulate, okay, and the angle addition postulate is real simple. All it says is the sum of two angles that share a common side will always equal the measure of the third larger angle. So like I said, angle OMN is our larger angle. We can easily see that all I have to do is add this small one with this small one, and I can get the measurement of the large one. Okay? We can write this out as an equation, or I can simply add them together. So here, LMN we said was this small one, that's 30 degrees. And OML, well, that's the other one, that's 120 degrees. And measurement of OMN must be 30 plus 20, must be 150 degrees. Okay? So the problems aren't going to be that easy, though. They are going to involve algebra. So let's take a look at this problem. It says find the measurement of angle ABC. So first off, I'm going to look at the diagram and I'm going to find my angle. So we want to know the measurement of this small angle right here. It says if the measurement of DBA equals 3x, this angle here, and measurement angle ABC equals 2x. So the one piece that's going to give it away is this one right here, and it says measurement of DBC equals 120. So that's the big angle. And again, all I have to do is say the two small pieces, this one DBA, 3x plus 2x, the other small piece. If I add them together, I should get the large one, and the large one equals 120. Okay, so now we have a simple algebra problem that we can solve. We get 5x equals 120. We can divide by 5, and we should get 24 degrees. Okay, but I'm not done. Okay, most people want to stop when they see x. That's what we usually do in algebra, but in geometry, we always have to look at what our question is asking. And it says, find the measurement of ABC. So really, I want to take this number and multiply it times 2. So my real answer is the measurement of angle ABC equals 48 degrees. Okay. We also have congruent angles. So congruent angles are angles that have the same measure. Okay. We also have angle bisector. Angle bisector is simply a ray, line, or segment that cuts an angle into two congruent angles. So these two definitions kind of go together with each other. So if you look at our diagram here, I have, again, 3 angles. I have angle CAB, the large angle, and it's being cut in half by this angle bisector, AD. Okay? And we always show congruent angles with this little mark here. It's showing that they each have 1. That means that this angle is congruent to this angle. All right? So if we look at example 3, it says find the measurement of angle EFG. Well, EFG again is this small angle, and we have these two little hash marks, or these little curves. So that means that this angle is equal to this angle. But we also have that little box, and remember that little box tells us that the big angle is equal to 90 degrees, right? So if the big angle is equal to 90 degrees, and these two pieces make up that 90 degrees, well then all I should have to do to find out what the small angle is take my 90 and divide by 2. So 90 divided by 2, the measurement of angle EFG should be 45 degrees. Okay? So that's measure and classify angles, and we are done.